Okay, I hope. Okay, I think I'll. Yeah. So this is visible. So I would like to thank Aditya
When
for letting me know
solving the
puzzles for the last 5 days. Mm, yeah. So the screen is visible now, and I can now show my coding editor. Cool. So it's visible now. We'll get started with the puzzles then. A brief fall later, you find yourself in a garbage smasher. Unfortunately, the doors magnetically sealed. Cephalopod cephalopod math doesn't look that different from normal math. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. We have this list of numbers along with these operators down below, and each problem's numbers are arranged vertically. At the bottom of the problem is the symbol for the operation that needs to be performed. Okay, and we just have to perform that operation. So if this is multiplication, and the numbers are 123, 45, and 6, so it's 123 cross 45 cross 6, which is 33210. Similarly, for this addition operator, we are adding all the three numbers and we get this number as 490, and so on and so forth. So, mm, are given the grand total of adding. Once we have these numbers, which is the output of multiplication or addition of these numbers, we just add those and print the output. I think we only have these two operators, added or multiplied. We don't have any other operators, so that is one less of a problem. And yeah, the thing is that we must now think about how do we actually parse this. This is a parsing problem again. Is the screen not visible? Okay. Okay, it's visible now, so that is cool. Mm, okay, so the screen is visible. This is the first time I have been streaming on both the platforms, so I'm a little bit paranoid that the stuff is visible fine. Um, okay, okay, so and I hope the audio is also good, and the chat is also open on Twitter, so anyone can just type anything if needed. Mm. Okay, so coming back to the problem, we have these numbers that are, so this is a, we can think of this as an Excel sheet maybe, and we have all these numbers and we need to parse them. Now, the first thing that comes to my mind is that I cannot simply just split them on the basis of spaces, because if I do that, the spaces are variable first of all, and there's no guarantee that. Okay, but we just have to do this operation on the whole number. Therefore, I think we can split this on spaces. Okay, I'll just read this whole thing and I'll split this on spaces and multiply the first column, the second column, I'll just add it. Similarly, for the third column, I'll multiply the numbers and I'll finally add the result, and that will be the output. os.open file, os.open input.txt. and input and error. If error not nil, I'll create this file input.txt where I'll just copy this input. And now it will be buffio.new scanner. This will be actually file. So we are reading this file using os.open, and then we are creating the scanner object. For line in range scanner dot scan. So we'll keep scanning until we encounter the end of file, and this is the first line. I'll also just I'll have this input array, which is simply an array of string. Input is equal to append input comma line. So n is the length of this input array, which is the number of rows that we have. And we know that the last row, the nth minus 1, the n minus 1th row, it is actually the operators. And operators string dot split operators, we are splitting this on spaces, and we'll also trim this. We'll just remove all the spaces, like all the prefix and suffix spaces, and then we are splitting this on the space operator. We're trimming. So strings.trim takes this cut set, trailing Unicode characters, all leading and trailing. We are just trimming this on spaces, and then we have the operators list, and then we are splitting it on spaces again. I'll call this as underscore operators. So the final operators output that we have is an array, and I'll just print this operators because I have a feeling that we'll also get empty string. Okay, so for some reason it is picking this last thing, uh, which is because first of all I'll rename this as inputs. Okay, because I was doing it, eventually I was doing this as n minus 2, which is wrong. So if the length of inputs is n, the last row is n minus 1th row, and that is the list of operators that we have. Running this as go run main.go, we have this list of operators. And just to confirm, I just want to confirm that we don't have any trailing spaces for these operators. This is just kind of a hack. And as you can see, we are actually reading the spaces also. So basically we need to trim this thing. So I'll just use as double underscore, because even this is not our final list. So our intermediate list would be underscore operator, and for each of them, and this is something that is easier done in Rust, but since this is Go, we must use this other convention. uh, we have this var operators. So for all these operators, what we want is, we want to string dot trim operator, and we need to trim all the spaces, and operators is equal to append operators comma this thing, and this is actually a temp string after trimming it, and if temp is not equal to empty, only in that case we are just like adding all the operators here to this operators list. This is one thing. So we have parsed the operators. Parse operators. I'll just check again that the stream is going well enough. Okay. I hope adding all the operators. Okay, the voice is fine. The screen is also visible. I hope in case of YouTube also it's good enough. Okay, but I don't think I have a lot of viewers here, but yeah. Use this other. Cool. So YouTube is running fine, X is running fine, and yeah. So continuing with this puzzle. Now what we did is we just read this whole sheet, and the last line is a line of operators, and there are many additional spaces that we don't care about, and then we have these numbers, and based on the operator type we just need to do the operation for these numbers. This is something, the last line is something that we have parsed already, and if I just print the operators here, if I just print it up, uh, now we have all the four operators and they are without any spaces. So we have like four proper operators here as it is shown in this problem, and we just need to parse these numbers then. So parse numbers. Now what do we do here? um, so again, actually this is something that we can make a function out of it. um, so let's call this function as, I don't know, clean parsing. Clean parsing takes in a string and returns an array of string. I'll just call this as ret, which is the return type, and I'll call this return function. And this is like just removing any additional spaces. This is one thing. So we will just do this thing, then yeah, I think this should be enough. So clean parsing. clean parse is the function. So clean parse just cleans everything and parses everything. So we have the string. We'll just first trim the string. So if there is any additional space, for example, on the left or the right side, as you can see, like for some of the numbers, we have spaces on the left side, and for some, we have spaces on the right side. We are removing those additional spaces, and then we have this string of um, characters along with spaces in the middle. So how do we handle it if it is a space? So first of all, we just trim it and remove any prefix and suffix spaces, and then after that we split the whole thing on spaces itself, because it can be variable in length. Like we can have a set of like multiple spaces between two numbers, and then what we are doing is that uh, for each of the character that we have, we just trim it again on the basis of spaces. And if it is a non-empty character, we are pushing it back to the string. Um, and this is something that we should do here. So we are pushing it to ret, and instead of operators, I think better naming would be temp, and this would be a single temp. I'll just write comments here, remove any suffix and prefix spaces, then split the whole thing on spaces, then push only cleaned out string to the output. Okay, so this is clean parse function, and once we have this, I'll just do inputs n minus 1, and this is clean parse. We'll get a list of operators, and now what we want is a list of numbers. What we want is a list of numbers, and actually we want a list of numbers, because this would be a, like in this case it would be a 3 cross 3 matrix. So for str in inputs, I'll also use this as index. If index is equal to n minus 1 break, or if index is less than n minus 1, then do these operations. So what is the operation here? We'll get a list of nums, which is actually a string, and we'll do a clean parse on this. This will return us a list of numbers, and for each of the numbers to int array, and this takes in this numbers, and nums is equal to append. Now I just need to implement this function to int array, which takes in so it takes in string, an array of string, and gives us an array of integers. And what we are going to do is this is very repetitive code, and this is what I don't like about Go, that you always need to write this repetitive set of codes. Maybe I can create a library like Advent of Code library that can be used for this purpose specifically. I think that would be a very good thing to do. Uh, so ends is equal to append ends comma n. Yeah, this should be okay. So we already have this operators parsed, and then we have these numbers. And uh, what we have to do is so how many number of columns we have, that is the length of operators. I'll call it as n columns. For I equals 0, it is actually j. So we are parsing this columns wise. We are finding the result like for each column. And for I equals 0, I less than n minus 1, because we know that n minus 1 is the proper list of numbers, and the last one is actually the operator. If operators j, or I think it's better to use switch case, that is more readable. So for the jth column that we are referring, what is the operator in that column? If the operator is star, then we multiply. If it is plus, then we do something different. Um, Actually, this loop will be inside it, inside this thing. So for the jth column, if the operator is star, then for all the rows, we uh, I'll just call it as result is equal to 1. Result is 1, and then result is multiply um, multiply nums I comma j. So for the ith row and jth column, we are just multiplying that number. And similarly, if this is the case, then result is 0. And for I equals 0, I less than n minus 1, I plus plus, I plus plus result is plus equals to nums I j. And final output, mm, final plus is equal to result. Similarly, we will do that here. And we just print the final thing. It is 42,77,556. 42,77,556. So yeah, I think this solution works. And we have this very weird looking, weird thing. I can't even begin to describe this. Whoa. I mean, I'm so scared right now. I can't even explain. Yeah. So I don't know how dangerous looking this thing is, but yeah, I hope our parsing can solve this thing. This is the answer that we have, 39689 something something. And I'll just put this answer here. That's the right answer. So we were able to solve part 1 of Advent of Code day 6, and let's continue to part 2. The big cephalopods come back to check on how things are going. When they see that the grand total doesn't match the one expected by the worksheet, they realize they forgot to explain how to read this math. So cephalopod math is written right to left in columns. Right to left in columns. Okay. So column 1, column 2, but right to left. Each number is given in its own column with the most significant digit at the top and the least significant digit at the bottom. Okay. Problems are still separated with a column consisting only of spaces, and the symbol at the bottom is still the operator. So reading from right to left one column at a time, the problems are now quite different. The rightmost problem is 4 plus 431 plus 623. Uh, what are they saying? Are we going to use the digits here? So I'll just zoom here. For this column, for the last column, we have 4 plus 431. This is 4. This thing is 431. And since we don't have anything here, it is assumed to be nothing. Therefore, we have only this single digit number, which is 4. I'll also use this on the diagram. So we have 64, 23, and 314. Okay. We have 64, 23, and 314. I'll change the color here. It's green. Uh, we have this first thing that is paired together. Then the second thing paired together is 431. And the third thing is 623. Since we don't have anything here, it will be read as 4. This will be read as 431 from top to bottom, and this is 623. Now, can you see the problem here? The problem is that we cannot simply use the same code back again, because here we are just parsing the numbers and everything. And I mean, we could have used the same code again for like each column, like processing each column. But now the problem is that if we just consider this second column. So for second column, we have like 51, 51, 387, and 215, 215. Now the grouping is like this. 175, 581, and 32. This is very different from the first grouping that we had. So if we just go ahead and use the same parsing logic that we have been using, that won't work. Because in the first case, the rightmost side did not have anything. So we had the single digit number. But in the second case, that is for the second last column, the leftmost side did not have anything. So the number comes out to be 32 because this part is missing here. But if we had used the same logic, if we had shifted 51 on this side, then our output would have been wrong. So how do we go ahead with this? Clearly, one thing that I can observe is that this operator, the index of the operator is actually the starting point. So the index of the operator is actually the starting point. And up till the next index, we can take this whole thing. I think that would be a good approach. Okay. So up till this point, we can take this whole thing, then till this point. And how am I creating this line? This is being created by operator itself. So if the operator starts from here, just before that index, we have this whole thing clubbed together. Similarly, before this operator, we have this whole thing clubbed together. And clearly, this would be a matrix. This would be a matrix which we can divide like this. And the last one would be a space. So we can read this whole thing as a single block, a single matrix. And this whole thing is actually governed by multiplication. And we can just iterate from left to right. We can see everything. If it is blank, then okay, not a problem. If it is not blank, um, then we just like take that number, and that would be one single number. So 32 would be the one number that we have. Then we have like 581. So 32, 581, and 175. And we just like concatenate those numbers, and since we have this multiplication, then we can simply multiply that number. I think this is the algorithm that we are looking for. So between two operators, just take everything as a whole single matrix. This is the whole matrix that we have. Similarly for this, we will be taking the matrix, and similarly for this. Yeah, I think it is pretty simple now that we have thought about it. uh, Maybe like what we can do is, then this would be, we would have to do like, yeah, still, I mean, we will have to think about the way we are going to parse this. It won't be that easy to solve, but let's see. I think this is a pretty interesting parsing problem that we have. Mm, okay, so yeah, I think we have the solution, but we just need to think about the way we will parse this. Yeah, let's get started. I'll call this as main 2 or something. I think, yeah. I mean, we will still use the functions from the first part. I mean, at least the operator parsing thing. But we won't be using this clean parse for our integer array. And we won't be using this toInt function. Okay. I think, yeah, this is it. So first we read the input just like we were doing before. And we have this operators that is clean parse. We are just using that clean parse function again to parse the list of operators that we have. So that is good. Um, but for I think if like we are considering two operators and we are considering the substring between those two operators, then we can just put that um, in the array. Hmm. Um, we have this columns array with us. Yeah, man, I'm tired. This is too much parsing. Sometimes I think, why did I come into this domain? Why did I choose software engineering? Like, why? Why do I need to parse it this much? So what we are going to do is, we have like, first of all we need to know the number of columns that we have, which we can know from here. So operators, number of columns is actually the length of operators array. So now we have the number of columns, and what we need is that we want to parse everything on the basis of column. So we need the first column data, the second column data, the third and fourth column data. And each column data will have the set of numbers. So column wise numbers is equal to make string n columns. And we know that these column wise, the length of these would be n minus 1, because like we have n, for example, if n is 4 here, then we have like three rows per column. So the number of rows would be like n minus 1, where n is the total number of rows for this worksheet. So we have these column wise numbers, and then what we have to do is that for each operator, because the numbers can be variable in length, so we will have to take the whole thing. Operator indexes. I think if we just have the index of operators, that should be fine. Operator indexes. So some of the time I'm using this array of int, but other times I'm using make array of int, which is like not a, which is the same thing, like, so don't need to worry about that. And range inputs n minus 1. So this is the last row, is the operators row, and if c equals star or c equals plus, operator index so we just append the index here. So now we have the operator indexes. Yeah, then this problem becomes easier now that we have the indexes. So for each row, we just need to have the number between those two indexes, between the next index and the first index. Yeah, I think that is okay. If I just explain like this, so this is the part that we need to divide this into. So we just need to have this substring, and that should be okay, I think. So for each row, so for the first row we do this thing, and it is part of that column. Okay, so first of all we just iterate over all the rows for I equals 0, I less than n minus 1 I plus plus. This is the first row that we have inputs I. This is the row under consideration. Now for all the operator indexes, we just put that in the column wise numbers list. And it is actually a array of string. Yeah. So column wise number 0 would contain the first column's numbers, which is like these three, 123, 45, and 6. So that would be the first column numbers. And for I equals, for operator index equals 0, operator, I'll call it as OPI. OPI equals 0, OPI less than um, n columns minus 1, OPI plus plus. OPI operator index OPI, operator index OPI plus 1. So we are taking the current index into consideration and the next index, and strings dot I don't know how do we take this. Oh, okay. We just don't need to worry about that. So like there's an easy way to take the substring. And how do we do that? This is actually string of this is the string under consideration. So if this is the operator index and this one is the other operator index, we need to take everything for this part. And now we are doing it for the first row. This is for the first row. And where is it going to go? This is going to go to the first column. Similarly, for the second row, it will go to the first column, second column, third column, fourth column. So for each row, it will go from first to last column. So for each row, so column wise numbers 0 would have, oh my god, this is very confusing. I think so we can make this column, this final nums matrix. So instead of saying it as column wise nums, we can have this final nums matrix, which is simply this thing. So it will be easier to reason about. What will be the size of this matrix? It would be the number of rows into the number of columns. The number of rows is n minus 1. and the number of columns would be this. Yeah, I think this is fine. So for each row from I equals 0 to n minus 1, then we are considering each column. This is the first, second, third, like that. So where is this number going to? For each row, we are considering each column. We don't even need to do this. Or actually, we can do this. Pi ij. I'll just call it as j, which is the operator index j. This is 0. This is the first column, second column, third column, fourth column. So 0, 1. This is the first thing. Then 1, 2. This is the second thing. Then 2. And then in the end, we have final nums I n columns minus 1 is equal to this whole thing. N columns minus 1. Yeah, the last operator, the n column minus 1th operator, and from that index to the last index. Yeah, so this is why it's confusing, because now we have this is the thing that is storing the index, and then we are using the index inside index, which is like kind of confusing. So we need to initialize the array here. And I'll just print this thing. I want to see what is being printed here. Why is this complaining? There is some issue. Okay, this n. I'll just use the older input. And let's run this program. Now we have this issue, undefined clean parse. I don't know why, but I'll just use this function here. Okay, can you see this now? Like, let's see that 64 has a space in the end. So 64 has a space in the end, which is good, which is correct. Similarly, 23 has a space, 23 has a space, and 6 has like 2 spaces before that. So that is also accounted for. Similarly, 98 has a space and 215. I think, yeah, this is pretty cool. This is what we wanted. Now, what do we need to do from here? Now we have this matrix defined. So for each column, now we need to iterate over the rows. So let's say that this is the column under consideration. Now we just go over the rows and append the number. Mm, for each column, for j equals 0, j less than n columns minus 1, j plus plus. For each column, um, and we iterate over the numbers from this side to this side. So we didn't even have to parse the numbers. We could have just iterated between the indexes after all. So that would have been okay too. Which is fine. I think what we are supposed to do here for each column, yeah, we don't even have to worry about this. So this was not needed actually. This was not needed. Mm. Let's reverse the operator indexes. Can we do that? Can we reverse? Hmm. Okay, now again, I don't know where that function is. Maybe like slices dot, oh, reverse is a function. Okay, slices dot reverse. What we have to do is we need to reverse the operator indexes, and it does in place reversion, which is cool. So now we have the operator indexes reversed, and for index equals 0, index less than n columns, or what we can do is length of operator indexes minus 1, I index greater than equal to 0. So let's not reverse it for now. So the last operator index gives us this index, the index of this operator. So from here to this thing, like this whole part we are iterating over. And then we want a combination of this thing. We want a, or I think this was cool, but oh my god, this is complex parsing stuff. I mean, it is not that complex, but this is pretty confusing. We are very close. We have done this thing. This thing is with us. Now I need to find the maximum length of this thing. And then I need to go over the whole stuff, and which gets pretty like frustrating, to be honest. Hmm. Okay. I'm just thinking how can we like solve this in the easiest possible way, which is also pretty readable and understandable. Oh, I think what we can do is cool for each array. So we need a from comma 2. From is the index of this operator and 2 is the index of this operator. So for each operator we have from 2, which is the index of the next operator. Let's just write this. So okay, so this is cool. Let's not touch this thing. Now for each operator, we have from, which is the operator index, and 2 is operator indexes, current index plus 1. Then this is okay. Else 2 is actually we did not even need this thing. We did not even need to parse this. So once we have the operator index, we already know where to from where to where we need to scan from. So we can just do that for our inputs. Hmm. Yeah. So 2 is actually is actually it is mm, length of inputs minus 1. Actually length of inputs. Yeah. So we have the operator indexes stored with us, and for the pair 0 comma 1 operator index, we know that this is where we need to iterate from and to. Similarly, for the second operator, we need to iterate from this side to this side. For the last operator, which is the number of columns, which is 4 in this case, the last operator from is the index of this operator. From is the index of this operator, and 2 is actually the length of this whole input. So we iterate from this index to the end of this whole input. That is what we are going to do. Yeah, we don't even need this final nums thing. So this part is gone. Now we know that we have this from and we have this to. We just need to iterate from there to there, from to actually. Okay, okay. Mm, and the pairing is actually from for that whole column. So for all the rows, so if we just fix that from, we just need to have character from all the rows. Cool, cool. For I equals, actually this is j equals from, because this j is fixed, from j equals from j less than 2 j plus plus. We need to have the number need to have. Okay, we have decided this from to do. Now for from to 2, now for each row, for I equals 0, I less than n minus 1, I plus plus. That is the character that we are going to have. So it is actually inputs I, j, and when this is done, we just append it to number. And we just remove the additional spaces from, we just trim out all the spaces that we have. I'll just print the operator index. And I'll print the nums array, and I'll also print one additional empty space. Okay, and now we have panic and everything. So obviously there is some issue here. 0, 4, 8. So where are we referring this index? I don't do this thing, and yeah, there is some issue with this only. This is n columns minus 1. Okay. Because this is the check that we wanted to have. If it is the second last column, then we have the 2 is actually the last index of the whole length of string. So when we have this last column, then 2 is actually the length up till here, till the last part of this whole string. So yeah. Now we have this empty array again. Oh, it is 124, 356, which is wrong. 124, 356. Oh, I think which is correct. 124 and 356. So this is correct. The parsing is being done correctly. For the second line, it is 369, which is correct. 369, 248, and 8. 369, 248, and 8. Awesome. But for some reason, hmm. Okay, it's because of this. Okay, we have the numbers now. Okay, and for the last index, we don't have anything. Okay. I also need to print from and to. So we are very, very close. I know this has been very frustrating, to be honest. Okay, for some reason, this 2 is 4, which is correct. Sorry, which is incorrect. So it's 0 to 4, then 4 to 8, then 8 to 12, and it should be actually 12 to the end. And it is actually not inputs but inputs 0. Oh my god, so many mistakes, and these are such silly mistakes. Can't even. Okay, now actually we are going to use this function toInt. Once we are done with this parsing, and this was so frustrating, to be honest. This is a result where we will be adding the numbers. Operator index, and we already have the operator index. We will also uh, operator index will also know the operator, like which operator this is. And we have this nums array which we will convert to int. And we have this result that we need to print. So this is actually, I'll call this as product, which is 1. And for product into num, and this is actually a plus operator. So we're now printing the result. Yeah, actually this is a very small code. We just had to think about all the parsing that we are doing. Okay, and now we have this thing from do. Let's try to debug main.go 53. What is wrong with this? Operators. Okay. I think we should use this correct index because okay, this is a parsed operator, so we can't use this operator index because I was thinking that we have this whole string out of which we are picking this indexes, but this is already a clean parsing thing is done. So the operator that we want is the operator at the current index. Yeah, so that is okay. 3263829. 3263829. 3263829. Oh my god, this is again wrong. Like we are off by 2 digits. Mm. So initially we have operator star and the number is 124,356. 124,356 and the operator is star. Then we have 369, 248 and 8 and the operator is plus. Then we have 32, 581, 175, 32, 581, 175 and the operator is a multiply. Then we have 4, 431 and 623. The operator is plus. So what is wrong here? Oh my god, because this should be some 0 because 0 is the additive identity. I just copied this thing here and like we had all this issue. Yeah. So now we have so we just need to get our puzzle input, which is this weird input. And this should work now. This is our number 60 something something. Yeah, and this is the correct answer. So we were able to solve this problem again, but it took a lot of time, and it was like too much. We had to do like too much of efforts. So yeah, I mean, I'll just post this. So yeah, I mean, I'll just. So where are we referring this index? Yeah, okay, so we were able to solve this, and I'll just remove this part because this is not needed. And this is the end of stream for me, and I'll see you in the next one tomorrow. So I hope you had some fun at least, because I did not. But yeah, okay.